Hello viewers, welcome back to Strictly Coding. Hope you are having a wonderful time. In today's video, I am going to clarify the concept of function as far as programming language is concerned, and I will be discussing function within the context of C++. First of all, I'll explain what a function is, then I'll be discussing certain terms, certain jargons that we need to understand, and we should be very clear about those terms to understand function properly. And then I will show you on my screen that how to write a function in C++, what are the different components of a function, and how to write and call a function and send parameters while calling a function, if any, in different ways. So let's begin. When we talk about function, you can think of it as a black box, which is also can be thought of as a third-party service provider. Now, why I say that? We can call it, we can treat it as a black box because we do not know what it does, how a task is achieved by a function. So a function is given a task. As I said, it also can be treated as a service provider. So we call a function to do something to us, to do some service to the caller. Now when you talk about caller, the caller of a function typically is another function. So within the context of C++, as you know, we can write procedural program as well as object-oriented program. Now, if it is an object-oriented program, naturally your program can have classes, and the classes can have its own member functions. On the other hand, if you think of a typical procedural program, like the program you can write in C, then all the functions will be typically global functions. But anyway, we are going to discuss the concept of function, whether it is a global function or it is a member function of some class. We can call the member function as method. Okay, so we will be covering all these things gradually with the help of example. But first, let us convince ourselves that function is a service provider. So we call a function to do something for us. That means a function can call another function to get some smaller task which can be outsourced to the called function. Now, for example, suppose as a faculty member of an university, and if I am a function, then my job is to actually conduct class. So if conducting class or conduct class is a function, then that conduct class function actually focuses on the activities which need to be performed to conduct a class. So if we consider those activities as statements, so a function is nothing but a bunch of statements enclosed within the function block, and if that conduct function is called, then all the statements inside that function will be executed. So we all know that for C++ programming language, main, quote unquote main, is the function which is the starting point of the execution. So main function will not do all the detailed tasks for which the program is written. So most likely main function will call other functions to do some task, and those functions can also eventually call other functions to delegate some of its subtasks to them. It is black box because when we call a function, we are not at all concerned, we means the caller function, not at all concerned how that task is achieved. So suppose main function calls a function called quote unquote do sum. So do sum is a function which does something for main. So main function is only interested in calling the do sum, and if do some need some input data to work on, then main function, which is the caller function, actually can provide that input as parameter while calling that function. However, main function is not at all aware or interested in knowing how that do some function actually does something with the input data. So that is the advantage. It's like outsourcing the task. So you outsource your task. So you are a big bank or insurance company, and you outsource your security service to some security management company, for example, Group 4 Securities. So the insurance company need not to bother about all the detailed protocol, detailed mechanism of managing the security of the insurance company, where that Group 4 security can be considered as a function which is called to manage the security of the insurance company, where the insurance company itself is a function because it called the security company. So the caller function actually can concentrate on its core activity. That means the activities associated with insurance business. So that is the basic idea of a function. Now, before getting into the code and show you the basic structure and explaining more for C++ programming language, let me clarify some terminologies that we need to be aware of. Now, when we talk about a function, there are the first term that comes into our mind is function definition, number 1. Number 2 is function call. Number 3 is function prototype. So we need to be able to distinguish what is what. Now, when we talk about function call, it is the statement written inside the caller function body as a statement, as one of the many statements, and it ends with semicolon. Now, for example, if the caller function, for example, main function, suppose main function has 20 lines of codes having different statements. For example, it is calculating the factorial of a number, and then it can actually, instead of calculating the factorial itself, main function actually can take the input from keyboard and store it in a variable called x, and once the factorial of x is calculated in another variable called, let's say, result, and it also prints the result onto the screen. However, the calculation of factorial part can be delegated to a function called calculate fact. So calculate fact is a function. So the main function, which is the caller function, will call the calculate fact by sending the x as the parameter while calling the function. So the statement will looks like calculate fact within parenthesis, x is the parameter, semicolon, that's it, and that is the function call. So function call has very simplistic structure, no return type, no type of the parameters. Only thing is you name the function and put the parenthesis, opening and closing parenthesis, end with semicolon, that's it, and that is the function call. Now if you want to provide some input data to that function to work on, it may be necessary many cases. Sometimes a function can be too generic so that it's not working, it does not work on some specific data, rather it does some common thing. In that case, you may not need to provide any input to that function. But even then, you have to provide the parenthesis with the function name to indicate to the compiler it's a function call. So in that case, in between parentheses there will be nothing, okay, no input will be given. So that is function call, the first thing. The second thing is, second term that we need to understand is function definition. In layman's term, we can call that as function body. So when you want to define a function, you are defining what task that function will do. So if a caller function calls this particular function, what this particular function will do. That's what we are defining, and that's why it is called function definition. Now, when we say we need to define a function, we need to define certain things which are mandatory. One of them is what this function will return once it executes all the statements associated with its call. So we have to provide a return type. Then we need to use the function name, open the parenthesis, and then I have to specify how many parameters this function use to take inputs from the caller. Now suppose in case of factorial calculation, calculate fact function takes only one input from the caller. In our case it can be x. So now first I have to decide how many inputs is necessary. If not, then it will be blank. If any, then we have to tell how many, and we have to tell what are the types for each of them. For in case of calculate fact, the parameter type will be integer because x can be an integer, suppose. So we tell that within the parenthesis int and then some parameter name, let's say x, and then close the parenthesis, and then we open the block with the curly braces, open and then close, and inside that block we put all the statements associated with that calculate factorial function call. So return type followed by function name, parenthesis, all the parameter list, providing type for each of the parameters, closing parenthesis, open the block with curly braces, put all the associated statements, close the curly braces. That is the function definition. Now other than very specific special purpose functions like constructor, destructor, which are associated with class object orientation, and we will talk about these special functions in future videos. But in general, almost all function must have a return type. Now what can be the return type? What the return type actually signifies? Now what happens unless we do some sort of parallel computation, any program actually is a serial program and all the instructions are executed sequentially one by one. So if main function is the starting point, control starts executing the statements one by one, and if one statement is completed, then only it will start executing the next statement, and once the second statement is completely executed, then it will move to the third statement, and so on, and it will continue till the end of the main program. And once it reaches the end of the main program, main function, your program terminates. However, if we make a function call as a statement in between, then let's say as the fifth statement there is a function call, let's say calculate fact, x is the parameter, semicolon. So after executing first four statements, we encounter a function call which is the calculate factorial, and then what will happen, control will jump to the definition of the calculate factorial. So after executing the block of the calculate factorial, all the statements, the control need to come back to the caller function, which is main here, and continue from the sixth statement. That is why when a function completes, it needs to return the control back to its caller. So if main function definition inside the do factorial function is called with semicolon, when that statement is encountered while execution, control actually jumps to the definition of calculate factorial function. Now once that all the statements are executed and the factorial value of x is calculated, control should come back here and continue with the rest of the statements of the main function. That is why the function should return, okay, the control at least, to back to the caller. Now oftentimes a function need to return some output data, calculated data back to the caller, not only the control but also the associated result. So in that case, return type should specify what type of data the function return to the caller function, so that the caller function can receive that data if it wants to and continue with rest of the statements. If the function returns only control back to the caller, suppose there is no data to be returned, in that case also there should be a return type, and then return type is void, because void means nothing. So because it's not returning any data, so it cannot specify any type for the data. But that void return type indicates it will return only control back to the caller. But if the return type is float or double, that means the function after execution returns a fractional value back to the caller. So that is the return type. And then the function name, and then if you provide multiple parameters, then you have to specify type for each of the parameters, give a name, and then after the parenthesis is done, you open the block and provide all the statements. So that is function definition. Now third thing, before we jump into the code, look into the code, is the function prototype. Now function prototype, the literal meaning of prototype, actually the same meaning applies here also. It actually gives an identity to the function. It actually gives the basic information about a function. It means a prototype of a function actually consists of the return type, function name, parameter type, within the parenthesis, semicolon. That's it. No function body. That's a one-line statement. Okay, so it's a one line of code for a function. Now your actual function definition may contains 200 lines of code. Okay, do something can have 200 lines of associated code, but the prototype of do something will be only one line and with semicolon, but it's not function call because it has return type, and also it tells the type for each of the parameters. Now why it is important? Now suppose in your program you have the main function here, and before main function you write the calculate factorial function. So when compiler scan the source code for compiling your program source code to produce the executable machine code, when it encounters the lines, it actually checks whether those lines are valid or not. Is there any error or not? Because if it is syntactically error free, then only it can convert our human readable source code into executable machine code, so it can build. So therefore, when it comes through the definition of calculate factorial, which is written above main function, it gets an idea about the calculate factorial because it scans the whole definition of the calculate factorial function. Now when it comes to main function, which is defined beneath, and inside the main function it identifies a function call of calculate factorial, it can actually verify whether this is a valid call or not, because it already has the information about the function do factorial. However, if you define the do factorial function definition after main function definition, and if there is a call of calculate factorial within the main, now the compiler encounters the function call without having any idea about the definition because it is yet to be scanned. There actually the function prototype comes into picture. So if you have several functions, potentially tens of functions in your program, then it is sometimes difficult to ensure that the definition is given for any function, the definition of that function is given before it is called by another function. So for one or two function you may be able to manage that, but if the number of function grows, then it is difficult to ensure that. And sometimes it becomes impossible because there can be cyclic call. Suppose function A calls function B, and then function B calls function C, and then function C calls function A. So since function A calls B, you put the definition of B before function A, and function B calls function C, so you put the definition of C before function B, but function C calls function A, so now A resides here. Now you need to pull A above the C, but that again restrict B to call C, you see, C to call A. So that's a problem. So that is why it is quite common to add one line prototype for each of the functions at the beginning of the program, so that you don't need to actually worry about the order of the definitions of those functions. It really doesn't matter which definition comes first, which definition comes later, because at the top of the program you provide prototype for all the functions. So enough said. Now let's look into the source code. So I'm going to add a Codeblocks project. So let me put the project name as C++ function 1. Okay. So I'm opening Codeblocks. As you know, to write a program we need a text editor, and to convert our source code to machine code and build, we need some compiler and builder linker. So all these things are packaged together in IDE's integrated development environment, and there are many: Microsoft Visual Studio, Dev C++, Codeblocks. Okay, there are many, Eclipse, NetBeans. So Codeblocks is a lightweight IDE, and it works for almost all platforms. So I'm using Codeblocks to explain the C++ coding concepts in this playlist. So let me create a new project. I am creating it as a console project, and I am giving a name of that project, but before that I'm choosing the language. So as you can see, we have two options, C and C++. So I'm selecting C++, and I'm giving the project title C++ functions part 1. Okay, so that is the project name, and of course there will be some destination of the folder, so I can select the folder also. Okay, so I have selected a folder, and it will create a main.cpp, that is the main program, main C++ program within this project by default, but we can add any number of C++ programs into our project. But anyway, the main will do for us. So if I click on the source, as you can see here, the main.cpp is already created in our project folder. So this is the project folder, and under the project folder there is a source subfolder, and in that source subfolder, sources subfolder, all the source code files will be there. So we have only one right now, that is main.cpp. So if I double click, it gets opened. So now if you look into that code, it already has a function called main, and the return type is int, and it has a statement to print the text hello world onto the screen. So if I compile and build it, so if I play, after successful build, it's printing hello world. So nothing much is done here. So that is the main function. The main function is the starting point. It's a special function. The main function is the only function which we normally do not call from within our program itself. So it is automatically called at the runtime, and we call other functions, if any, from main, because that is the starting point. So control will jump from main to other functions, and it will eventually come back after completing all the function calls that we intend to make, and finally it will return, since the return type is int, so we need to return an integer here. Now 0 is an integer, we know that it's a whole number, but we can return any whole number. We could return 10, minus 53, whatever we want, but 0 signifies the success code. So if the caller of main, which is the runtime environment, receives the 0, then it understands that the main function is completed successfully. It did not crash somewhere in between. Okay, or intentionally we could return non-zero if we find some anomalies while executing the function. So at runtime we could check for some flag, and if we see that that flag does not hold the desired status, then instead of returning 0, we could return some non-zero value in between the statements at checkpoint, and we could avoid executing rest of the function, and we can return. That means terminate. But anyway, so the example that I discussed, that is calculating factorial, I could actually I'm going to write a function. The best way to write a factorial function is using recursion, but we are discussing the introductory level concept of functions, so I assume that of course you can be an experienced programmer. So in that case, I appreciate for you being with me, but I'm also assuming many of my audiences are newcomers. They're learning the programming language. So in that case, I'll implement the factorial calculation not using recursion, but using a normal for loop. Okay, so what I need to do, I need to call a function, let's say call calculate factorial, but for that factorial of what? So I need to ask user what is the value. So I'll declare an integer, so int, let's say x, and I'm asking user cout enter a number and enter a number, and we take the input from user, so scene x. Now as we know that integer is a 4-byte data type, so it can only represent a number whose binary equivalent is maximum 32 ones and lowest is 32 zeros, because 4 bytes means 32 bit. So therefore it cannot store a number larger than 32 ones in binary, and it also cannot store a number smaller than 32 zeros. But wait, not all the 32 bits are used to represent the data, because the most significant bit is used for sign bit. So you only have 31 bits. So 2 to the power 31 is something like 2 to the power 32 is 4 billion plus, but if you take out the most significant bit to represent the sign, positive or negative, then you only have 2 to the power 31, which is 2 billion plus. So your range is minus 2 billion to plus 2 billion. And naturally factorial value will be positive number. So you can, if your factorial value is within 2 billion plus minus, then you are good to store the factorial value in an integer. Now suppose you are trying to find the factorial of 55. That will be way more than 2 billion, so you cannot store that in an integer. So that's a different discussion. But now, right now, let's focus on calculating a very fairly smaller number, let's say less than 10, and we'll call a function for that. So we are assuming, I make a comment, assuming the user input will be a positive number greater than 0 and less than equal to 10, for example. So we have taken the number x. Now we need to make a call. So as I said, function call will simply have the function name. Let's say calculate factorial is the function name, and semicolon, that is the function call. So now this calculate factorial function will calculate the factorial, but for whom? So we need to provide the input to that function, which is in our case x. Now you see, if you look here I only provide the x, no type. I did not say what is the type of x, because that is the thing I need to define when defining the function in function definition, that what should be the type of the parameter, what type it should return. So those are the actually defining the characteristics of the function. But here we are making a call. So when we are making a call, it is already defined. We just send the parameter what we are going to send as an input, in this case x. So we call the function calculate factorial by passing the parameter x. Okay, so that is function call. Now we need to have a function definition. So now definition actually tells when the calculate factorial will complete, it should return the control back to the caller. In our case, this is the main function is the caller, because we are calling inside main. So when the calculate factorial will return, will it return any value, or it will only return the control? Now see, we want to, if we want the result to be printed by the calculate factorial itself, then we may not need to get the value back. In that case, void is fine. However, if we want the result to be printed in main, then we may need to get the result from the function. So I'll show you both the version. Now first one is let's say I give the function name get factorial. Okay, so get, instead of calculate factorial, get factorial. Okay, and let's say suppose there is another function called print factorial. Okay, so print factorial. So the name is more intuitive. So print factorial will actually calculate the factorial value and print there itself, so it don't need to return any value. So return type of print factorial can be void. On the other hand, get factorial means, the intuitive name suggests that okay, so probably we are trying to get the factorial value at the caller function, which is main, so that main can actually use that. So let us say another variable y. So enter first number, so in x. Now we are actually doing the same thing for the second number. Okay, so enter second number, see in y. Now we are calling print factorial by sending x, and we are calling get factorial by sending y, but we need to get the factorial value, so we need to receive it. We may or may not receive it, but we want to receive it, so let's say int result, or let's say int fact value equal to get factorial. So get factorial function is called by sending y as input, so it will calculate the factorial value of y and it will return the result along with control back here at this point, so that it will be received in fact value. So now we can print the factorial value. So we can say cout the factorial of y is the result that we received in fact value, so fact value. Okay, so we made two calls, one call for print factorial function, another call of get factorial function. Get factorial function returns a value, so we receive it in fact value. So now let us write the definition of both these functions. So first let us write the print factorial. So since it does not return any data, only control back, so return type can be void. So void print factorial. There is a parameter, so now we need to define first of all how many parameters. So that is the block of the function. How many parameters? One parameter, because we are passing only x as parameter as input. So, and what is the type of that parameter? Whole number, which is integer. So now we say here int. Now you can give any name, pqr, whatever. So let's say val. And now our job is to find the factorial value of val. We could very well use recursion, but as I said, recursion is advanced level function, so special. I am using simple loop. Okay, so to run the loop, I need a loop variable, so int I. So for I equal to, now we know that factorial is nothing but, factorial of val is nothing but val into val minus 1 into val minus 2 up to into 2. So we can run a loop from 2 to val. Okay, so I equal to 2, I less than equal to val I plus plus. And we also need a result. So let's say result, okay, which is initially we assume that it is 1, so we initialize it with 1, otherwise it will be multiplied with garbage. So now within the loop, what we do, we say result equal to result into, so we can say multiply equal to I. So it will be keep multiplying, okay, 2 with 3 with 4 with 5 up to val. So that is the result of that is the factorial of val. So now since we are not returning the factorial of val, so we can actually print it here. So cout, so I can just copy that, the factorial. Okay, so the factorial of val is result. Okay, so that is the example of function without returning any data, but definitely it needs to return the control. So we are telling we are not returning any value, so the type of the value is void. So it means control will be back here once it is done. Now we need to write the get factorial also. So return type is integer, so we write the get factorial here. So int get factorial, again int val. Now I can copy the same thing here. But now I need to return. So once the loop is completed, so I need to return result. So now this result now contains the factorial value of the parameter, which is val, and that once it is completed, it will return that result. So it will be received in fact value, and we can print it here. Okay. So if we execute the main, first it will show on the output window that enter first number. So we type a number, then it will prompt the user enter second number. So we type the second number, then we call the print factorial with x as parameter, the first number. So it will go there, calculate, print, and control will be back. Then we call the get factorial with the second number as parameter y. It will go there, calculate factorial value, and it will return that factorial value. We receive it in face value, fact value, and we print it here. Okay. So let's build and run the whole thing. So that is the whole code. So it is asking, as you can see, let me zoom it a little bit. Okay. So enter first number, let's say 6. Enter second number, let's say 7. And the first call actually prints the factorial of 6 is 720. And the second call returns the factorial value of 7, which is 5040, and it is printed by main. So that is function definition and function call. Now what about function prototype? Now if I show you the code once again, here when the compiler tries to compile this code, it starts scanning the code from top to bottom, and first it encounters the definition of print factorial. So compiler by this time already knows what the print factorial returns, which is what, how many parameter print factorial has, 1, and what is the type, integer. So when it encounters the call print factorial x, it can actually checks it whether the call is valid or not, no problem. Now after scanning print factorial, it starts scanning get factorial, and it also have the idea, okay, get factorial now returns an integer. It takes one parameter, and the type of that parameter is also integer. So when it encounters the call, it can verify, okay, y is the parameter which is integer, and only one parameter that matches, and it return value is received in int, so that also matches. So it can make a conclusion, okay, it's a valid call. And that is why it's working, because definitions are given before the calls are made. So calls are made inside main. This is the first call, this is the second call, and both the definitions are available to the compiler scanning before the call is encountered, so no problem. Now suppose you have so many functions. Now suppose this get factorial definition, I just cut it and I paste it after main. So now what happens, the code is absolutely fine, but when compiler make a scan from the top to bottom while building the project, so it has information about the print factorial. So when it encounters the call, no problem. But when it encounters the call for the second function, get factorial, parameter y, it is returning something which is stored in an integer. Is it a valid call? It has no clue, because you don't have any idea about the function, because the function definition is provided afterwards. That is why the prototype is important. So the prototype is giving an identity to the function, just one line identity at the top of the program. So just you can simply provide here int get factorial int semicolon. Okay, so prototype is not called, so that is why it is not inside any function. As I said, the caller of a function is another function at the beginning. So now without this prototype, if I try to build, I will have a compilation error. You see that compilation error is given, and the error is if you see here, the get factorial was not declared in this scope because it does not have any information about get factorial, which is actually there at the below, but at this point of scanning, compiler doesn't know that. But if we provide the prototype, then even though the definition is given below, but it has the identity of the function. That means what it returns, how many parameters, and what is the type of each of the parameters. So now even though the definition is at the below, but it will be built, okay, because of that prototype, compiler has this information and it is working fine. Okay, so factorial 2 is 2, factorial 3 is 6. So that is the first part of the function, because we'll be discussing more about functions, maybe 2 or 3 more episodes. So I'm stopping here. So hope this helps you. If you like this video, please give a thumbs up, share it with your friends, and also consider subscribing and press the notification bell button so that you keep getting all the future updates. Thanks for watching. See you in the next video.